Hello, everyone. In this video, I will share with you how to perform point cloud tiling. First, we should know that why the point cloud data need to be tiled into blocks. As we know, for a big project, the entire survey area may be divided into multiple subsurvey areas. Each subsurvey area will plan the route and collect data according to the sorties. When an aircraft or UAV flies along a route, it can only obtain a narrow strip of point cloud data. However, when we produce surveying and mapping products, such as digital high-level models, contour lines, and other topographic maps, we often need to produce data according to standard subframes. Or when the amount of data is relatively large and exceeds the software and computer memory limits, this time requires us to retile the point cloud data. Of course, in addition to the regular shape, there are irregular shapes in the tiling operation. In order to consider the data consistency of the edge area, when tiling, it is often necessary to set a buffer to ensure that the edge area can get correct and complete processing results. In fact, there is another way to tiling point cloud data based on existing polygon grids or index diagram. For this point cloud data, we will tiling the data according to the existing polygon grids. We can get such an irregularly shaped tile result. Of course, we can draw this polygon in advance or now. In addition, if the polygon already exists, we divide the point cloud data of the entire survey area into tiles, and do not require each point to be divided into corresponding tiles. We can divide the point cloud of interest into areas of interest. The tiling work at this time is more similar to cutting. Well, we use the existing polygon to tiling the above point cloud data to obtain the point cloud data of the two regions. Next, let's take a look at specific cases. For example, in this area, we can see that the point cloud data is collected according to the airstrip. Each airstrip corresponds to a point cloud data in loss format. Other times, our loss format point cloud data may correspond to a relatively large area. For example, this area is about 40 square kilometers. At this point, we also need to do data tiling work. A large area of loss format point cloud data is divided into many small areas of loss format point cloud data by tiling. In the PCA Viewer software, we open this tool for point cloud tiling. We can see that a total of 6 point cloud tiling methods are provided. The first is a regular shape, which requires the user to enter the number of rows and columns. The second is to tiling in a square manner. In this case, the size of the tile is strictly specified by the length of the block. In the field of surveying and mapping, standard tiles are usually carried out according to the range of 1 km by 1 km. The third is to tiling the point cloud data according to the existing index diagram. The fourth is to tiling according to the trajectory, which will not be repeated here. The fifth is to draw the polygon of the tile in real time and then divide it into tiles. The sixth is to specify the size of a single file for tiling, which will eventually be converted into the first method, calculating a number of rows and columns for tiling. Let's emphasize again that it is always necessary to set the distance of the buffer when dividing into tiles, in order to expand the range of each standard division and ensure that the production results do not have large errors at the edges. Next, we open the point cloud to be tiled to see how to tiling the point cloud. There are 9 point cloud data in loss format. After opening, you will find that the information has been updated. These statistics include the minimum X value, minimum Y value, minimum Z value, maximum X value, maximum Y value, and the maximum z-value of the outer bounding box of the entire point cloud data. Based on this information, we can also calculate the length in the x-axis direction, the length in the y-axis direction, and the length in the z-axis direction. This information can help us to judge the setting of tile parameters. Of course, when we divide the tiles, we can further modify the range we want to output. I won't repeat it here. Let's say we tiling according to this regular shape to specify the tile size, modify it to 1200 meters, and set the buffer to 50 meters. Let's take a look at the results of the tiling of this point cloud data. Here we can change the output path. After the tile is successfully divided, a dialog box will pop up and tell us the time it takes to divide the tile. Next, we load the tiled point cloud data. The results of this tile are consistent with our expectations. You can contact us by email at jonas_zinc@gmapp.com or WeChat at +86 13888837 1238. Alternatively, you can obtain a trial license by filling out the relevant information on the website https://www.thjymap.com/pca. Thank you for watching and see you next time.